Welcome back, guys, and in this tutorial we're going to be looking at arithmetic sequences. Now, arithmetic sequences is one in which each term changes by a fixed amount, usually through addition or subtraction. Now at Junior Cert again, we would have referred to these as linear sequences, which are very similar. Now if you turn to page 22 in your log tables here, you're going to see some of the formulas that we're going to need. Starting off in this tutorial, we're going to be looking at the Tn formula, which you can see on page 22 of your log tables. Remember from our first video, Tn is our general term, which is equal to a plus n minus 1 times d. Now a, as you can see here, is your first term, T1. D is your common difference, which means it would be your bigger term minus your smaller term. So T2 minus T1. And this formula written in general notation is Tn minus 1 is equal to D. So that means your term minus your term before that is equal to your common difference D. Now this is a rule that we're going to use to prove that a sequence is arithmetic. Okay, which we're going to come back to in a later example. So to look at the basics here to start, the first one here says find the nth term Tn of the arithmetic sequence. So the first thing I check is what does it go up by each time, and I can see that it goes up by 5 each time. So that means I know that a, my first term, is equal to minus 2, and d, my common difference, is equal to 5. So to find Tn, I now write out my formula, a plus n minus 1 times d. So a I can see is minus 2 plus n minus 1 times d, which is 5. Now even though it's written after, we're going to multiply that 5 by the 1, by the minus 1 and by the n, which gives me here minus 2 plus 5n minus 5. So 5n usually comes first, minus 2 minus 5 gives me minus 7. So therefore Tn, my general term, is 5n minus 7. Okay? Part 2 here asks me to find T20, and part 3 asks me to find T21, which is another way of saying to find term 20, which means all I have to do is take my 20 and sub it in for n. So I'm going to have 5 by 20 minus 7, which I know is going to be 100 minus 7, which gives me 93. So term 20 is 93. I'm now going to do the same thing to get term 21, where I have 5 by 21 minus 7, which gives me 97. And part 4 here asks me to find, T21 minus T20. Now T21 minus T20 is the same as having our 97 minus 93, which gives me 5. Which you can see here is my common difference D. And remember, we said that one term minus the term before that should give us our common difference D. So we've proven that the series is arithmetic. Okay, so that's example 1 there, guys. If you want to pause the video, you can to go back over it, and then we're going to move on to example 2. So in example 2, again it gives me a linear sequence, an arithmetic sequence, and the first thing I always do is I find my common difference, which I can see it's going down by minus 4, and I can see my first term is a. So I have a is equal to 1 and d, my common difference, is equal to minus 4. But this time it asked me to find the number of terms. And when it asks me to find the number of terms, it means I don't know n. But what it does give me is the final term, minus 251. So what I'm going to do here is, again, I'm going to take my general formula, Tn is equal to a plus n minus 1 times d. And to find what term gives me minus 251, I'm going to sub it in here for Tn, because I know that's the value I would have when I find this n, is equal to 1 plus n minus 1 times minus 4. So again, I'm going to multiply it out here now, which gives me minus 4n plus 4. So again, minus 251 is equal to minus 4n plus 5. I'm going to bring my 5 over, or minus 5 from both sides, which gives me minus 256 is equal to minus 4n, and so now to find n, I'm going to divide both sides by minus 4. And when I divide both sides here by minus 4, what you should see is we get n is equal to 64. So what that means now is that term 64 is equal to minus 251. Now something key to note here, guys, is when we're solving for n, the number of a term has to be whole and it has to be positive to be in the sequence, which means really n has to be an element of natural numbers. So that's something important to note in these questions. Alrighty, time for example 3. If you want again, guys, and you need to take a minute to go over what we've done so far, you can pause the video here. But otherwise, we're going to crack on into example 3. So again, in this one, it says an arithmetic sequence. T4 is equal to 6. So it's telling me that term 4, so n equals 4, is equal to the value 6. And that 3 by term 2, so we know n is equal to 2, is equal to term 10. And it says find the values of a and d. So I'm going to do this as part 1 and I'm going to leave this second part as part 2. So T4 is equal to 6. I know my general formula, Tn, is equal to a plus n minus 1 times d. Well, they've told me the value again is 6, so I'm going to sub in 6 here. Then I have a plus, and I know n is going to be 4 because it's term 4 times d. Now what that gives me is 6 is equal to a plus 3d, which is an equation with two variables. And I know that when I have an equation with two variables, that I need to have a second equation with two variables to be able to solve it. So I'm going to go again here, where I have 3 by term 2 is equal to term 10. So this time it doesn't tell me the value, but it tells me that when n is equal to 2 and I times it by 3, it will give me term 10. So I'm going to use my general formula here, but instead of n, I'm going to put in 2. So that's where my a plus 2 minus 1 times d comes from. And then here I have a plus 10 minus 1 times d. So that gives me 3 by a plus d is equal to a plus 9d. So now I multiply both terms by 3, and I'm going to bring everything over to the same side to get 2a minus 6d is equal to 0. So now I have two equations which I can put together using simultaneous equations to solve for a and d. So that means I have a plus 3d is equal to 6, and I have 2a minus 6d is equal to 0. So now I'm going to times the top line by 2 in my simultaneous equations. So I get 2a plus 6d is equal to 12. 2a minus 6d is equal to 0. I add both lines together and my 6d's cancel, which leaves me with 4a is equal to 12, which means a has to be equal to 3. So now I'm going to pick the top equation and try and solve for d. So instead of a, I'm now going to sub in 3, which gives me 3 plus 3d. Oh, sorry here, guys. 3 plus 3d is equal to 6. I bring my 3 over, so I get 3d is equal to 3, which means d must be equal to 1. So I've now found a and I've found d, my first term and the common difference, which is what it goes up by. It then says hence write out the first 6 terms in the series. Now I could use this to get my general formula Tn, or I can just say, well, if a is the first term, that means it has to be 3. And if every term after that has to increase by 1, I'm just going to keep adding on 1 to each of my terms, which would give me 3, 4, 5, 6, 7, 8, ... as my first 6 terms. So again, guys, that's now example 3. So if you want to pause the video here, take a second to go over it or to try it yourself. We're then going to move on to example 4. And example 5, which will be our last two in our arithmetic sequences. Now example 4 says, if p plus 2, 2p plus 3, and 5p minus 2 are 3 consecutive terms. Now be careful with that word consecutive. Consecutive means one after the other. Okay, which means that these come after each other in the pattern of an arithmetic sequence, but it doesn't necessarily tell me that they're the first terms. So that means ... we would have p plus 2, then the next term would be 2p plus 3, the next term would be 5p minus 2, and then it would continue. And it asked me to find the value of p. Now this is where we're going to go back to our rule that we mentioned before, that in an arithmetic sequence, I know that tn plus 1, so the larger term, minus tn, the smaller term, will give me the common difference d, as long as they're consecutive. Which means if I say that he's tn, and he's tn plus 1, and he's tn plus 2, then tn plus 1 minus tn should give me d. Okay, so tn plus 1 minus tn should give me d, but it also holds that tn plus 2 minus the term before it, tn plus 1, should also give me d, which means that means tn plus 1 minus tn would have to be equal to tn plus 2 minus tn plus 1. So now I'm going to sub in what I know. That means I'd have 2p plus 3 minus p plus 2 is equal to 5p minus 2 minus 2p plus 3. Now be careful here. That minus on the outside is going to make him a plus, it's going to make him a minus, and it's going to make him a minus. That minus on the outside will make him a minus and him a minus, which means here now I end up with 2p plus 3 minus p minus 2 is equal to 5p minus 2 minus 2p minus 3. So that gives me p plus 1 on this side is equal to 3p minus 5 on this side. So I'm going to bring my 5 over and my p across, which means I get 1 plus 5, which is 6, 3p minus p, which is 2p. So nice and simply now I have p is equal to 3. So again guys, if you want to take a second to pause it there, that's my example 3 here, or example 4, and our last example we're going to do on arithmetic sequences is we're going to look at example 5. Now in example 5, it asks us, it gives us two TNs, two general sequences, and it asks, is the sequence arithmetic or not? To prove a sequence is arithmetic, we're going to use our rule again that tn plus 1 minus tn should be equal to our common difference d, which in this case, since we don't know it, we're going to say is a constant. And remember, a constant is just a number without a variable, without an n. And we're going to check then, when we get that constant, if the sequence is increasing, which means that the number of values is going up, that means our common difference, d, should be greater than 0, or nice and simply, it should be positive. If it's decreasing, that means that the numbers in our sequence are going down, which means our common difference would need to be less than 0, which means it would have to be negative. So to try and test this one here, if we look at the first pattern, we have tn is equal to n plus 1 over 2. To find tn plus 1, anywhere I see an n, I'm going to sub in n plus 1, which leaves me with n plus 1 over 2, which is really n plus 2 over 2. So now I'm going to minus them. So I have tn plus 1 minus tn, and I'm going to see what I get. So I have tn plus 2 over 2 minus n plus 1 over 2, which is quite nice because we have a common denominator. This guy here is going to be a negative, and he is going to be a negative because of the negative out here, which means when I add them together, I get n plus 2 minus n minus 1 all over 2, which means I'm left with a half. And that half there is actually my common difference. So now I can say in my conclusion, therefore it is arithmetic. And it's always very important to have a conclusion in these questions, as tn plus 1 minus tn is equal to a constant. And that constant that it's equal to is d, and I can see d is a half, which is greater than 0. So the sequence is increasing. So you can see here I've actually answered part 1 and part 2, or part A and part B, using the same method here. So to finish up here, we're going to look at the second sequence that it's given me, which is Tn is equal to 2 over n plus 1. So again, the same steps. Tn plus 1 would be 2 over n plus 1, which gives me 2 over n plus 2. But now, to take these away, we need to be careful, because that will leave me with 2 over n plus 2 minus 2 over n plus 1, which means to take these away, we need a common denominator. And a nice little bit of revision of our adding and subtracting algebraic fractions. To get a common denominator, I'm going to combine the two of them and multiply, which means on the top now, I need to multiply 2 by n plus 1 minus 2 by n plus 2, which will give me 2 by n plus 1 minus 2 by n plus 2, which gives me 2n plus 2 minus 2n minus 4, all over n plus 2 by n plus 1, which leaves me with minus 2 over n plus 2 by n plus 1, which you can see now I have variables on the bottom, which means therefore it is not arithmetic, as Tn plus 1 minus Tn does not equal a constant. So if I want to find if it's increasing or decreasing, the easiest thing to do here is to find term 1, term 2 and term 3 and see what happens. So term 1 would be 2 over 1 plus 1, which would be 2 over 2, which is just 1. Term 2 would be 2 over 2 plus 1, which would give me 2 over 3. So I can see it's starting to get smaller. The next one would be 2 over 3 plus 1, which would be 2 over 4, which is giving me a half. So I can see that as I go from 1 to 2 over 3 to a half, that it's getting smaller and smaller. So therefore, the sequence is decreasing. Okay? And guys, we're going to wrap it up there on our arithmetic sequences. Our next video is going to be looking at arithmetic series. So see you then.